stuff that we've learned. So we've already covered inequalities. We're going to talk about those again. Then we're going to talk about how to use the inequalities to compare whole numbers, negative numbers, so integers, fractions, and things like that. And that's probably what we'll get to today. We'll also talk about absolute value, which is something I don't think we've talked about at all yet. Once we get through all that, tomorrow we're going to use the idea of inequalities, but then we're going to compare expressions rather than just single numbers. You'll have an expression to simplify on one side and an expression to simplify on the other. So maybe something like, negative 434 plus 320, and then you want to compare that to, say, negative 768 plus 512. So you actually have to do both of the operations, get their answers, and then compare the answers. That's going to give us a lot of really good review for the final exam. So, once we get through Thursday, remember, all next week is basically 3 days of review and then the final exam. I would highly suggest that you start reviewing, if you haven't already, start reviewing for the final exam sooner rather than later. You don't really want to start next week. Next week will probably be a little late. Do remember that if you go to our class website, if you go to Final Exam Prep right here, there's 2 different versions of the final exam for you. So if we click here.
Can we see our answers on that?
No, not on here. It'll have the answer key. So here's practice final exam version 1 and version 2. And then I've got versions 3, 4, and 5 that we're going to be looking at in class come next week. Okay? So you will have access to several versions of the final exam. So nobody will have to say, oh man, I didn't know this kind of problem was going to be on the final. We'll have seen the final basically up to 5 different times before you have to take the real one. So it should be basically, kind of old hat by the time you get it. My goal is that we get so much practice with it that everybody's like, this is going to be kind of boring. This is like the 5th time I've seen it, but I'm definitely prepared for it, right? It's all about making sure that no one has any anxiety by the time they hit the final exam. All right. And of course, it wouldn't be first class today afternoon if I didn't forget to plug in my receivers. There we go. All right, so the first thing we're going to do is a review of the relation symbols, right? When we say relation symbols, what we mean are symbols that relate one expression or quantity to another expression or quantity. Then we'll do some evaluating of inequalities, and then we're going to talk about absolute value for a little bit. And then we're going to go and evaluate inequalities that involve both negatives and absolute values. All right. So relation symbols are symbols that relate one expression to another. So the one that we use most often is the equal sign. Okay, so if I see something like 2 plus 3 equals 5. This is the symbol that says that this expression here is equivalent to this expression here. If we want to go even simpler, right, we can say something like 5 equals 5. That would be it's pretty trivial, right? We know that it's true for sure, but that would be an example of inequality. Inequalities are things that are not equal, right? And if they're not equal, there's 2 possibilities. Either the first one is greater than the second one, or the first one is less than the second one. And so we're going to have 2 separate symbols here. So this symbol here, if you encounter reading left to right, as you would if you were reading in English, if you encounter the small portion of the symbol first, that's the less than symbol. So like this would say 3 is less than 5. if you flip that symbol around, so that when you're reading from left to right, you encounter the larger portion of the symbol first, that's the greater than symbol. So something like 7 is greater than 5. Okay. So we've got three possibilities right now. We can either use equality, 5 equals 5. We can use the less than symbol, 3 is less than 5. Or the greater than symbol, 7 is greater than 5. Okay. So three different relation symbols that we've used before. So what we want to do is we'll start off with the simpler ones, just using whole numbers. We've got 14 and then a blank line, and then 13, and we want to insert the correct relation symbol. And which symbol should I put in there? Greater than. 14 is greater than 13. So any questions there? So here I've got an 8 and a 0. So which symbol do I put in? Greater than, right? 8 is greater than 0. Here I've got a 5 and an 8. So which symbol do I use?
Less than.
Less than. 5 is less than 8. Here I have 28 and 30. So which symbol do I use? Less than. 28 is less than 30. Now, when we say greater, what we really mean is 14 is to the right of 13 on the number line, right? When we say 28 is less than 30, we mean 28 is to the left of 30 on the number line. You want to keep that in mind for when we get to the negative numbers. How about this one? Go ahead and use your clickers. Seconds. Excellent. So 48 is greater than 47. How about this one? Seconds. Excellent. 14 is less than 24. So now what we want to do is talk about absolute value. So absolute value of a number is its distance away from 0 on the number line. So if we think about a number line, 0 is in the middle, and then we know all the positive numbers are to the right. So 1, 2, 3, 4, 5, and so on. Right? And all the negative numbers are to the left. Negative 1, negative 2, negative 3, negative 4, negative 5, and so on. So the negative sign really is our direction, right? And we talked about that at the beginning of the semester. We said that every number has both a magnitude and a direction. Absolute value wants the magnitude of the number, and it doesn't care about the direction. So when it says the distance from 0 on the number line, we think of it like it's a measurement, right? So for instance, if I come over here and I look at 3, how many units away from 0 is 3? 3, right? 1, 2, 3. So it's 3 units away from 0. Now, if I come over here and I grab negative 4, how many units away from 0 is it? It's 4, right? So 1, 2, 3, 4. So the idea is that with absolute value, we use vertical bars if we want the absolute value. So the absolute value of 3 is 3, because 3 is 3 units away from 0. The absolute value of -4 is 4, because it's 4 units away from 0. What we're doing is we're kind of stripping off the direction. We don't really care about direction when we're talking about absolute value. There are lots of places where we use absolute value. So, for instance, in a car, right? When you have the speedometer. If I put the car in drive and I step on the gas, the speedometer may say I'm going 40 miles an hour. And I know since it's in drive, I'm going 40 miles an hour forward, right? If I were kind of crazy and I put the car in reverse and I stomped on the gas pedal and I started going 40 miles an hour, the speedometer is going to tell me that I'm going 40 miles an hour. It's not going to tell me that I'm doing negative 40 miles an hour just because I'm going backwards, right? So that is an example of absolute value. It cares about the magnitude, how fast, not in what direction are we going. Okay.
So the absolute value will never be negative.
So long as there isn't a negative sign on the outside of the absolute value, that is absolutely correct. So here, if I have the absolute value of 9, what am I going to get? 9. So the absolute value of 9 is equal to 9. And if I have the absolute value of -6, what am I going to get? We're going to get +6, right? Because it just takes the sign right off. All it wants to know is how far from 0 is this thing. So if I have the absolute value of -27, what am I going to get?
27.
27. Because it's 27 units away from 0. Don't care what direction it's going. If I have the absolute value of 48, what am I going to get? 48. Okay. All right. So what we know right now, we want to write this out in general, is that if we have the absolute value of some number n, we get n, right? If we have the absolute value of -n, we still get n, right? Pulls that negative sign. So, if there is no negative sign on the outside of the absolute values, our answer is always positive. So I'm always looking, I don't care what sign it has on the inside. I always just kind of ignore that. I'm looking at the outside. So if there's no negative on the outside, no negative sign outside of the absolute value bars means we're going to get a positive answer. Now, when we have a problem like this, the negative, let me write it over here. The negative absolute value of 4. These problems are a little trickier. When I see the negative sign on the outside like that, what that really means is -1 times the absolute value of 4.
So that would be a -4 then.
That's right. We have to take the absolute value before we can multiply. So the absolute value of 4 is, well, the absolute value of 4 is 4. So it would be -1 times 4, but -1 times 4 is -4. Remember, if they're different signs, we get a negative answer, and we'll multiply. So when we have the negative absolute value, when the negative sign is on the outside, we're actually going to get a negative answer. So the negative absolute value of 4 means what is the opposite of the absolute value of 4? Well, the absolute value of 4 is 4. The opposite of 4 is negative 4. Okay? And that is always true if there's a negative sign on the outside. I say, well, what's the absolute value of negative 18? That's 18. But then since there's a negative sign on the outside, I have to say, what's the opposite of 18? Negative 18. So notice that if there's no sign on the outside of the absolute value bars, I always get a positive answer. If there's a negative sign on the outside of the absolute value bars, I'm always going to get a negative answer. So here, if I have the negative absolute value of negative 29, what am I going to get? Negative 29. So the other possibility is that I could have something like the negative absolute value of n. That's going to give me negative n. Or the negative absolute value of negative n, which is still going to give me negative n. So if there is a negative sign on the outside of the absolute value bars, then I'm going to get a negative answer. So once again, just to kind of sum it up, you don't want to overcomplicate these problems. Don't pay any attention to the sign inside the absolute value bars. I only care about the sign on the outside. If there is no sign on the outside of the absolute value bars, I get a positive answer. If there's a negative sign on the outside of the absolute value bars, I get a negative answer. If you can remember to keep it that simple, then you'll get all these problems right. It's when students start to go, oh, wait a minute, a negative and a negative is a positive. No, that's the rule for multiplication. Okay? This is absolute value. It's a little different. All right, so let's go ahead and do some more example problems. We've got -1. We want to compare that to 0. So which inequality symbol do we use?
Less than.
Less than, that's right. -1 is less than 0. If you ever get confused on this, think of it as the balance in your bank account. You know, which would you rather have? A balance of -$1 or a balance of $0, right? Nobody wants a negative balance in the bank. Here we've got 5. Want to compare that to 2. So which symbol do I use? Greater. 5 is greater than 2. Now here, -5, -2. Which symbol do we use?
Less.
Less than, good. A balance of -$5 would be less than a balance of -2, right? You're further in debt at that point. Any questions?
Can our whole exam be this easy?
Part of your exam will be this easy, for sure. So here we've got 408. We want to compare that to -416. So which one do we use? Good. Greater, right? A positive number is always greater than a negative number, no matter what they are, right? Positive balance in your bank account, always better than a negative balance in your bank account. Now here, we start to get a little more complicated. what we have to remember here is that this negative on the outside of the parentheses means multiplied by -1. So -1 times -4 gives me what? So a negative times the negative is positive. So that's a +4. Over here, we've got a negative sign on the outside of the absolute values, so what are we going to get here? Negative 4. So really what we're comparing is 4 and -4. So which symbol did we use? Greater.
So you would have got messed up if you put equal.
Yeah, absolutely. Questions? All right, so here we've got negative and then in parentheses 82. We want to compare that to the absolute value of 46. Now once again, when we have a negative sign on the outside of parentheses like this, it really tells us to multiply by -1. So -1 times 82 is going to give me what? Negative 82. Different signs, right? The rule for multiplication says if they're the same sign, I get a positive answer. If they're different signs, I get a negative answer. So that's negative 82. And then the absolute value of 46 is 46. So I'm comparing negative 82 and 46, which is negative is always less than a positive. Any questions? All right, so here I've got the negative absolute value of 0. And I want to compare that to the negative absolute value of 1. Well, what's the absolute value of 0? 0. Is there a -0? No, so we just write 0. What is this? The negative absolute value of 1. What are we going to get there? -1, because the negative sign's on the outside of the parentheses. So we're really comparing 0 and -1. So what sign is greater? That's right. 0 is greater than a negative number, right? No matter what that negative number is. Any questions? All right, so here we've got the absolute value of -17. We want to compare that to the absolute value of 17. Well, what's the absolute value of -17? 17. What's the absolute value of 17? 7. That's right. So these two are equal. Any questions? All right, so go ahead and use your clickers and answer this. Not too bad. We should have less, right?
Oh, it has less not changed.
So when I think about this one, I think about my bank account. This is -$8, this is -3. A balance of -8 is a lower balance than a balance of -3. The other thing that you can think of is that less than means to the left of, right? So if we think about our number line, if this is 0, this is -3, that's -8. -8 is to the left of -3, so it's less than -3. How about this one? seconds. Excellent. Negative 12 is less than negative 8, or sorry, than positive 8. Go ahead and try this one.
Got some moonshine in the window.
No, I've got some water. About 15 seconds. Excellent. That's right. Negative 5 is greater than negative 24. How about this one? Seconds. Not too bad. So these should be equal. So here we've just got negative 8. There's nothing to do with this one. But here we can see that we've got an absolute value with a negative on the outside, which means it's going to be negative. So that will also be negative 8. So negative 8 are equal. How about this one? Seconds. Good. Greater than, right? Remember, this one means negative 1 times negative 7, and a negative times a negative is positive. So it'd be positive 7. Here, since the negative is on the outside, you get a negative 7. Positive 7 is greater than negative 7. How about this one? About 15 seconds. Not too bad. So we should have less than. This is negative 1 times 98, which would be negative 98. And this is the absolute value of 36. So this one will come out positive. A negative is always less than a positive. All right, so the next thing we want to do is look at using inequality symbols with fractions. So if I have 7 over 15 and 11 over 20. First thing I want to do is, if I'm going to compare fractions, I need a common denominator to compare them. So I need to find a common denominator between 15 and 20. Well, one way we can do that, right, is with multiples. So let's just try multiples first, because that usually tends to be easier if it happens fairly soon. So we've got 20. What's the next multiple of 20? 40. What's the next multiple of 20? 60. Okay. If we wanted another one, right, we could get one. It would be what? 80. But you don't want to write down too many of them, because the idea is to compare them to the multiples in the next one. So now we've got 15. What's the next multiple of 15? 30.
45.
45, and then 60. And there's our common denominator. Okay. Now, we would say 15 times what gives us 60? 4. Remember, all you have to do is count the number of multiples. 4. And then 20 times what is 60?
3.
3. So now 7 times 4 gives us what? 28. So that's 28 over 60. And then 11 times 3 is 33 over 60. So this is saying 28 sixtieths, and this is 33 sixtieths. Once you have the common denominator, you don't really need that anymore. We're just comparing the numerators. So we've got 28 and 33. Which symbol would we use?
Less than.
Less than symbol. That means in our original problem that 7 over 15 is less than 11 over 20. Any questions?
Why?
Hmm?
Is this what we're going to be doing?
Any questions before we look at the next one? We've got 15 over 4, and we're going to compare that to 21 over 6. Well, I'll tell you, the first thing that I always do is look for things that I can reduce out. So when I see 15 over 4, 21 over 6, I do recognize that 21 over 6 can be reduced because there's a common factor of what, Nick? 3. So 21 over 6, that's going to be 3 times 7 over 3 times 2, right? So I can cancel out those common 3's. So really what I want to compare is 15 over 4. There's no common factors there, so I can't reduce that one. And 7 over 2. That makes it a little bit easier to find the common denominator, right? What is the common denominator?
8.
It's going to be
8. 4.
4. Yeah, 4 would work, right? Because we can multiply 2 by 2 and get 4. You could have used 8. That's a common denominator. It would have worked. But 4 is the lowest one. So now what we really have is 15 over 4 and 14 over 4. So which symbol do we use? Greater. 15 is greater than 14. That tells us that in our original problem, 15 over 4 is greater than 21 over 6. Any questions?
Yeah.
Yeah.
Instead of having to reduce to 21.6, can you just, no, that would be too far. Never mind.
Okay. Yeah, there's lots of other ways to do it, for sure. Some of them are a little bit longer than others. The other way that you can do it is that you can convert both fractions into decimals using division and then compare their decimal answers.
And say 4 and 6 could go into, each one can go into 12.
That's right. So you could have gotten a common denominator for 12. That would have worked too. All right, so here we've got negative fractions. So this is negative 9 over 24. And comparing that to negative 8 over 21. Well, first off, 9 and 24, do they have any common factors?
3.
3. So let's go ahead, and I'm just going to write it as 9 over 24 for now. I know it's negative, but to reduce it, I don't need that. 9 is 3 times 3. 24 is 8 times 3. So we can cancel out those common factors of 3, so that's going to give us negative 3 over 8. Do 8 and 21 have any common factors?
No.
Nope, right? 21 is an odd number, so there's not going to be a factor of 2 in there. So we're just going to use negative 8 over 21. So now here, trying to find the lowest common denominator between 8 and 21 would probably be pretty labor intensive. We don't have to. If all we want to do is compare We don't have to have the lowest common denominator. All we need is a common one. We can get that by taking the first fraction and multiplying the top and bottom by 21. And then take the second fraction and multiply the top and bottom by 8.
I have a question.
Yeah.
Why couldn't you cross out the 8?
You can't, because this is not a multiplication problem. You're not trying to multiply these two together. What you're thinking of is if you had this. 3 over 8 times 8 over 21. When you have multiplication, you can do that. This isn't a multiplication problem. We're actually trying to compare these two. Now, the nice thing is, we don't actually have to do the multiplication for the denominator. We just have to know that they would be the same, right? Well, 8 times 21 and 21 times 8 are going to be the same, right? Whatever it is. It winds up being, I think, 162. You're right, 168. But we don't need to worry about that. Because we know that once we have a common denominator, what we're actually doing is comparing the numerators, right? So all we need to do is multiply the numerators. So negative 3 times 21. Well, 3 times 21 is going to give me what? It's going to be 63. And it's going to be negative because they're different signs. So that's negative 63. Over here, 8 times 8 is what? 64. And since they're different signs, it's going to be a negative 64. So what I'm really comparing is negative 63 and negative 64. So which symbol do I use?
Greater than.
Greater than. Good. Negative 63, if you think about it as a bank account balance, right? It's better to have negative $63 in your account than negative $64 in your account. Any questions? Yeah.
So, will that rule apply to all of these?
Absolutely.
So just times the denominator of the largest one?
Well, it doesn't even matter. What we're doing is we're just taking the first fraction, multiplying by the second fraction's denominator, and then taking the second fraction, multiplying by the first fraction.
And then don't worry about the denominator, just worry about the numerator.
That's right.
For all of these.
Yep, it would work for all of them. Yeah. All right, so go ahead and try this. Seconds. Excellent. Greater than. Another way of thinking about this, by the way, is visually, right? Of course, I wouldn't necessarily recommend you solve problems this way because it's a little bit more labor intensive. But if we think about 7/8 and 3/4, we know that we can model them, right? We can model them with those fraction bars. So 7/8 means I would take a fraction bar. The denominator tells me chop it up into 8 equal pieces. So there's 2, there's 4, pretty close, that's 8. And then the numerator tells me how many of those pieces to shade. So I would shade 7 of those pieces. Now, if I draw another fraction bar, I've got 4 equal pieces, right? Because it says 3/4, and I want to shade in 3. And if we see, if we kind of like do a little dashed line up there, we can see that in the first fraction bar, more of the bar gets shaded, right? That means that it's a larger portion, a larger quantity. Any questions? All right, so we're going to try this. Seconds. Not too bad. They should be equal. The easiest way to see that these are actually equal is if you remember to reduce the fractions first. So here I've got -3/12. So I'm just going to take the 3/12 for now. And I say, well, 3 and 12 have a common factor of 3. So 3 is 1 times 3, and then 12 is going to be 4 times 3. Cancel out the common 3's, that's going to give me -1/4. And now do the same thing with 2/8. Well, 2 and 8 have a common factor of 2, so that's 1 times 2, and then 8 is 4 times 2. So cancel the common factor of 2, and we get 1/4 again. It's still negative, so that's -1/4. Now it's very easy to see that they're equal. Any questions? All right, so tomorrow we're going to continue with inequalities. The problems are just going to get a little bit harder, okay, because there's going to be operations to perform on either side before we can actually figure out which inequality symbol